Hello, everyone. How are you guys doing today? So, our exam is tomorrow. I already did the review with you, so you know what to expect in the exam. There will be around 11 questions, 11, 12 questions, extra credits. How many what? Two,
Only two.
because these questions are bigger. It takes longer to 1 point each.
1 point.
Because in 100% scale, it will become 2 points.
Only 2 points.
You don't have to do it if you don't want to. The main thing is the required one. Okay, so I'm not, huh? Napkin. More? Here. What are you saying? What I was saying? I forgot what I was saying. Okay, anyway, so I already gave you all the information you needed for tomorrow's exam. Please study tonight very well. Study smart. And today we are going to start 2.10. We need to start because we don't have many days left. Today is 29, and I think we have few more days. So the next exam will be December 2nd or December 4th. So today is 13. So next week we have 3 days, and then the following week we have 1 day. So 3, 4, and then probably we have 1 day when you come back. So 3, 4, 5. 5 days. The next exam will be December 4th.
Is that one of this?
Yes.
When is the final?
Final is 17, December 17, 8 a.m. in the morning.
You can't change the dates.
Huh?
You can't change the date.
Final exam, no. Final exam is the departmental. Like if you have exams conflicts, then you can reschedule it. I think you don't reschedule the math one, you have to reschedule the other one. Yeah. As far as I know.
We will don't have PCAL final.
I'm teaching pre-cal, so yeah, with me you have only pre-cal final.
How about the other class?
They will tell you their finals. Ask them about the final date. They'll tell you. Every class supposed to have a final exam. So some structures like other classes like that is not.
English too?
Yeah, we should have final exam, but some structures they don't give final. Instead, they give final project or something.
Yeah.
Yeah. So other subject depends on the instructor, but math we must have to have a final. It's the departmental policy. Every math class. There is no project final. Not in the undergrad.
Is there
What?
is it good?
No. I'm going to give the quiz question in the exam. No. We're starting exactly. So do well tomorrow. And that question, I'll mark it as a quiz question. So you'll get points in your exam, and also you'll get points as a quiz.
Like every other there, right? That have.
No, the question I have in the exam, that is from the quiz question. William. Not extra credit. If you got that question wrong, but the exam question is right, then I'm going to take the exam question. Not tomorrow, but final exam is a calculated question. So every question tomorrow, there are smaller numbers to work with. You can do them by hand, not by hand, by hand. Okay, any other question? So we learned implicit differentiation. You may wonder, why do we need them in our real life? So today's topic is the real life application of implicit differentiation. We call it related rates. Means we have several rates, they are related somehow. Maybe you're observing a change in the distance based on the change in the time. So there are two types of rate. Change in the distance is one rate and change in the time is another rate. So related rate means you are relating two rates together. In many real life situations, we encounter cases in which several variables are related to each other and also are changing with time. Since the variables are related, their rates of change will be related, and hence problems of these types are usually referred as related rate problem. Jolene, no fun, please. For example, cost, revenue, profits, they all are changing with time. Today, maybe you are gaining profit, but tomorrow, you may lose the profit. You may face some loss. Revenue. Maybe today revenue is high, tomorrow revenue will be low, or maybe today it's low, tomorrow it will be high. So all these things are changing over time. We can use implicit differentiation to figure out all the things we need to know. We're not going to do many examples with money, but we are going to do examples with something like area, those questions. Now something easier to start with. Let's say we have a function y equals x cubed minus 3x. Now, previously in the last section, we said derivative of this. What's the derivative of y? Y prime. But this we cannot write prime anymore.
Why?
Because you're not changing over time. Sorry, you're not changing respect to x. All this change will be respect to time. So there will be no more prime because the denominator is not dx anymore. So previously, if you did it respect to x, it was dy dx.
Wait, is this on?
No, not tomorrow test. And what was the derivative of x cubed previously? What did we say? 3x squared, and we did not have anything extra. We did not have anything extra because it should have been dx over dx. We are taking the derivative of x respect to x. That's why they cancel out, so we never put dx over dx. And then what's the derivative of 3? 3. And then we did not put it, but we should have put dx over dx. Now, all this derivative we took respect to x, but in this section, we're not going to take the derivative respect to x. We are going to take the derivative respect to time. So all this denominator will turn into dt instead of dx. And see, now dx over dx doesn't cancel out because we don't have dx over dx. We have dx over dt. So anytime you take the derivative of x, also derivative of y, you have to indicate that. There will be nothing invisible anymore. Everything is visible. Okay? And they are saying that, they're asking that find dy dt as a number when the x value is 2 and the derivative of the x respect to time is 3. So we do the substitution here. 3x squared something minus 3 something. What is x? What is x given to us? 2. And what is dx dt? 3. So you take the derivative and you simplify after replacing all those numbers. So we have multiplication. 3 times 3 is 9. 2 squared is 4. Minus 3 times 3 is 9. 36 minus 9, which is 27. And that's all you have to do. Take the same derivative as the last section, but you have to indicate for every derivative of x, you have to write dx over dt.
That's it.
That's it. That's the difference. Try the next one. Same concept, same everything. This time they're asking to find dx dt. Let me write it bigger for you. We are given y cube is 2x, but this is what? What?
You write y to the power 3 as 3y squared dy dt.
Ready? Ready?
That is of y.
It says find dx dt.
Oh, wait. Oh. You can't plug it for wiring.
Oh, they did not give y.
Or just solve y first.
Or you can do it on the side.
Wait, original function would.
If you know your x, how do you find the y?
Fine.
Your y cube is 2x squared. So what is y? How can you get you the cubic power? Cube root. Cube root of 2x squared.
That's y.
So what is x? 2. So you have cube root of 2 cube. Cube cancel out, it's 2. So if they don't give you something, you know how to find it.
Also, you should study.
Erika, what's the derivative? Hmm? 3y squared dy dt perfect 4x dx dt perfect. And then they're asking for dx dt. What's dx dt? So how do you solve for dx dt? And then you divide it. Or you can divide by 4 at first. And then you can solve it. So our dx dt 3y squared dy dt divided by 4x. So how much is the y?
2.
2. They didn't give us, but we found our y here. Do you know what is dy dt?
dy dt is 4.
4. And what is our x? 2. So you can cancel out the 4. You have You can also cancel one of the twos if you want to make your life easier. 2 cancel with one of the two.
Yeah.
And then say 6.
What? I got
I mean-
9.5.
9.5. You cannot have 9 because it's not 3 square. It's 3 times 2 square.
Wait, hold up.
It's 3 times 2 square.
3 times 2 squared. Oh,
Mhm.
wait, 2? Wait, so
It's 3y square. So 3 times 2 square.
wait, so like 2 to the power 2 is 4, and 4 times 3.
It's 12.
Yeah, so 12 times 12.
12 times, how do you get 2?
Hey, you see my word?
Your dy dt is 4, not 2.
Which one? Wait,
3, 2 square, 4. So this is 12 times 4.
Yeah.
12 times 4 is not 36.
oh, it's 32.
No.
Wait, but 12, 24. Oh, 48.
Mm-hmm.
48. And 48 divided by 8 is 6.
Mm-hmm.
It's- Oh,
The answer is 6. It's easy, right? Not too much work. Let's see what we have next. Now comes the word problem. The actual word problem where we use this implicit differentiation. So for the last 2 examples, they already gave us the equation. Now you have to find out the equation and then solve the equation. So you have to do 2 things. But these are fun, these are real life. At what rate the area of a circle increasing? So let's say you have a circle here, and then you decide to make it bigger, and then you decide to make it even bigger, and then you decide to make it bigger. So the more bigger the circle is getting, the more area is consuming, right? The first circle has this area. The second circle has this area. The third circle has this area, right? The fourth circle has the entire thing. So you're making your circle bigger and bigger, bigger and bigger. When you're making your circle bigger, there are 2 things changing at the same time. Which 2 things?
radius.
Good job. One of them is radius. See here, this radius was this one. In the next one, this is your radius. It got bigger. For the next one, this is your radius. It got even more bigger. And for the last one, this is your radius. It get even more bigger. So 2 things are changing. One is radius. And what's the other thing? True. Radius or diameter, same thing. Radius or diameter, circumference, and other things also changing. Circumference. What else is changing? The area. So all 4 things, they are changing. They are changing over what? All these things are changing respect to time, over time. When you drew the first one, it took less time. When you drew the next one, it took even a little bit longer second. And then the next one took a little bit more second. So everything is changing over time. So all these things are increasing at the same time. Now this is, in this situation, they are saying at what rate the area is increasing if the radius is increasing at the rate of 5 feet per minute. So this a small radius is changing 5 feet per minute. In every minute is changing 5 feet. The next minute is 10 minutes. The next minute, right? 5 feet per minute means 5 feet per minute. So the radius we know is changing at what rate? They're asking, well, if you know the change in the radius, can you figure out the change in the area? If radius is changing 5 feet per minute, then your area is changing what per minute, at what rate? This is what you're looking for. Okay, that's the situation. So since we are working with area, we need to know the area formula. What's the area of a circle? Huh? Length times width is for rectangle. It's a circle. Sayon? Pi r square. So you have to review your, we are going to review together all those geometric formulas. Area of a circle is pi r squared. What pi means? Is it a variable or is it a number? Which one? It's a number. And what is r? The radius. So we have only one variable, the radius. So we can write area is a and then pi r squared. Now we are taking the derivative. Everything changing means we need to take the derivative. Anytime something is changing, if something has a rate, it means take the derivative. So area we are looking for, at what rate the area is changing, means what's the derivative of the area. So if you're taking the derivative respect to time, what's the derivative of a? How do you write a prime? Using two variables, you have to indicate it's changing respect to what? Respect to time. So you cannot write a prime anymore. You have to write derivative of a respect to time. So dA over dt equals, what's the derivative for pi r square? Good job. 2 pi r, but you also have to indicate the derivative of the r. How do you indicate derivative of the r? dr dt. Perfect. dr dt. So we take normal derivative, but the indication we always have to write it down. Hey, this thing is changing respect to time.
So you don't remove the R.
No.
So
It's
why?
So 2 pi r is pi r square. Okay. 2 comes down to minus 1, this 2 pi r. But then you have to write, hey, wherever we got the 2 pi r, what is this 2 pi r?
Oh.
So we are saying, hey, this 2 pi r is derivative of r respect to time.
But then why don't you like?
We did it. Derivative of a is 1 dA dt, but 1 is invisible. Derivative of any variable is 1. But we don't write that because 1 is always invisible. Not always, mostly 1 is invisible. Okay, now they're asking at what rate the area is changing. It means what is the derivative of the a? So we have 2 pi. Do you know what is r? Did they tell us what is r? 14. It says when radius is 14 feet long. So radius is 14. And do you know dr dt? It's at which rate the radius is changing?
5 minutes.
5 per minute. Rate of change for radius. Anytime something increasing, something decreasing, something getting bigger, something getting smaller, something changing, it's the derivative. Okay. So we have 2 times 14, 140 pi, and feet per minute.
So that's your answer.
So the area is changing 140 pi feet per minute. If the radius is changing 5 feet per minute. Do you know what's the value for pi? 3.1417. So it will be a big number, 140 times 3. Okay, so that's how we do this type of question. Try the next one by yourself. If something is increasing, so increasing means positive, decreasing means negative. So if you have a negative sign, it's not wrong, it just means it's something decreasing. Read carefully what is given and what is missing.
So it's like the same question.
Similar. Try to understand what is given.
We write A is I R squared.
You start with pi r square,
Right.
and then you look for what is given and what is they're asking to find.
Kind of like time and radius. That's good.
Hmm?
Is that time and radius? That's good.
Time is not given. The rate of change is given.
Rate of change. Wait, what's the rate of change?
Derivative. Anytime you see any type of rate of change
Research.
means derivative.
What?
Depending on what is changing.
Hmm.
What is changing? That means the idea of the derivative is given. The derivative of the idea is given.
So what will you find?
What they're asking for.
Rate of change
For what?
when the radius is 3.
Read the entire sentence. Find the rate of change of what? So what you are finding?
Radius.
No. What you're looking for?
The rate of
For what?
radius.
Good. So what you're looking for?
The limit.
Of? Good job.
Yeah. Yeah.
You tell me what is given.
All right.
Read the sentence. Read the sentence from beginning.
And rate of change.
So what is given? The area of a circle is decreasing. So what is decreasing? What is decreasing? The area at a rate of 5 pi over 6 square inch per second. So area is changing with this number. So what is this number?
That's the.
What is changing? Is it the area?
Oh, that's radius.
No. Read the sentence carefully. The area of a circle is at.
The rate is 5 over 6 per.
So what is changing in this sentence? What is changing?
The rate.
Rate of change means changing. So what is changing? Good. The area is changing. The area is changing at pi over 6. So what is this pi over 6? D what? What is changing?
Oh, dA over dt.
Area is changing. So this is dA over dt. Whatever is changing, that should go on the numerator.
You like go that's cool.
So you read this way. First you read and interpret each sentence.
Aim to work.
We are doing it together.
Oh.
The area is changing at a rate. Whatever rate they give you, whatever is changing is the derivative of that thing. Here the area is decreasing, means area is changing at a rate, means that number is the derivative of the area. Now they want us to find the rate of change of the radius. So what you are finding? The rate of the change, what does rate of change mean? Rate of change means derivative. So find the derivative of the what? Radius. So you're looking for dr dt. And they gave us this information. That's how you interpret. You read, and then you see what is given and what is not given.
So the area is 5 6 dA dt.
No, area is pi r square.
but how?
Area is pi r square for the circle. And then you take the derivative. What's the derivative of the area?
I6 dA green T.
What's the derivative of A?
D.
dA
DT.
over dt.
So I6 times that.
Pi over 6 square inch per minute. We don't have to write that. So this derivative of the area is pi over 6.
Oh, so
But
dA
first-
dt is I6.
Pi over 6, not pi 6, pi over 6. So first you have to find the derivative. And then you substitute. Now, what's the derivative of pi r square? We did it before. Derivative of pi r square? 2 pi r and dr dt. Now 2 pi, do we know what is r? 3. And we don't know dr dt. So we get pi over 6 equals 6 pi dr dt. Since your goal is to get this alone, what do you do?
Divide by 6 pi.
Divided by 6 pi. Divided by 6 pi. But it's a fraction division. So you do keep, change, and flip. So pi over 6, you keep it. You change the division into multiplication. And if you if you flip 6 pi, what do you get? 1 over 6 pi. Because below 6 pi, you have an invisible 1.
6 will be negative since it's decreasing.
Good observation. This is decreasing. So it will be negative. 1 over 6 pi equals dr dt. And now the pi change, cancel out. So we get 1 over what? 6 times 6? 36 equals dr dt.
Also, so like since it's decreasing, the A is negative.
Negative.
Right.
Decreasing means negative. So which of these choices you have? They give you the choice this time, right?
B. B.
The second. So this is what you have to do in the final exam. Show the correct work, circle the correct choice.
This is way harder than the other.
That's because you're just learning it for the first time. Almost.
Almost.
Thank you. People have been getting sick recently, and all the homeworks due on the 16. Like people have like stuff due this week. Do like all the tests.
Whoa.
We cannot postpone the test because our next test will be soon.
Yeah, like, why do you think the meeting? All the homework due Sunday.
I think I changed the date, if I'm not wrong.
Like next month.
Yeah, not next month.
Oh, next month.
Next week or something, I think. 24, I think 24, 25th. I extended all the homework.
Wait, all of them like 2.10 and all that, or just the ones that up?
2 point some, chapter 2. Whatever we did not learn. 2.1, 2.2, 2.56, and we did 8 and this is 10. I can extend the homework anytime, no problem, but the exam is not possible to extend. You see, you don't have much time. One more last question about circle.
Also, that's plus. No, that's a positive.
Increasing means positive. Good. One last question.
So 12 pi is a derivative of A. Easy.
See?
I would.
Two? We have to check. I don't have the answer, but I have the choices here.
Yeah, he, the guess.
So you guessed it?
It just
Why did you guess?
It's just based on.
We will see. 12, and then you are dividing by
I. Raised to 3.
6.
I was solving for D or B2.
It looks like 2.
I'm looking hungry.
Or did you guess based on the position? The second position? Uh-huh.
Wait, wait. Wait, yeah, I think it's 2. Yeah, it's 2.
That's right, that's the bottom.
B2? Wait, so 12 pi divided by 6 pi, you cross out the pi, right?
Mhm.
Alright, so it's 2.
So what do you do?
Easy. It's easy. Like, wait,
It is easy.
this is easier than other.
Okay, what's the derivative of A?
DADT.
dA dt. And what's the derivative of pi r square?
2 pi r dt.
dr.
dr dt.
dr dt. And now what is given? Area is increasing with this rate.
4 pi.
So this is dA.
4 pi.
Well, pi
So
equals 2 pi
3 dr dt.
times 3 dr dt. So 12 pi equals 6 pi dr dt. And if you're solving for dr dt, they're asking for the rate of change for the radius. So if you want to get your dr dt alone, you need to do by 6 pi. So pi cancel out. You get 2 equals dr dt. Any question on this? So about circle, they will ask you 2 questions. Either what's the derivative of the area or what's the derivative of the radius. Based on the information you see, what is given and what they're asking for. Okay, the next scenario. It's a balloon.
I thought you said last one.
I said last one about the circle. There are many scenarios. The first scenario was circle. The next scenario is balloon. What's the shape of a balloon? It's a cone, right? What's the shape of the balloon? What do you call it geometrically? What shape?
Here.
Sphere. So they will not give you the formula, okay? You have to remember the formula.
Wait,
Balloon is a sphere, so you're looking for a volume of the sphere.
so like what shapes do we have?
All this question we are going to do here. Circle, balloon, rectangle, triangle. I think that's it. And square.
Only like 4, 5 shapes.
Yeah.
Alright. Not too bad.
Okay, right. So let's read this, what they are saying. A balloon is being filled with helium at a rate of 4 feet cubed per minute. So let's say you have a balloon here. Small balloon. And you're putting helium inside. As a result, what is happening to the balloon? Balloon doesn't get an area.
Huh?
Area gets 2D shape. Balloon is that 2D shape, right? What type of shape?
3D.
3D. So 3D gets what type of thing instead of area? What's the area in 2D turns into something in 3D? Do you know? Volume. It's the same thing as area, But area we refer for 2D things. But balloon is not 2D things. 2D is a circle. Balloon is a 3D. So you cannot say area of a balloon is changing. We have to say volume of balloon is changing, even though the same thing is changing. So the volume of the balloon is getting bigger and bigger and bigger. So when you fill your balloon with helium, what is changing?
Hey. What about
Volume. So volume is changing, means what is given here?
the
Derivative of the volume, dV.
Mhm.
Anytime something is changing, means the derivative of that thing is given to us. So when you fill the balloon with helium, the volume is changing, means the derivative of the V is given here. Now they are saying at what rate, feet per minute, the radius is increasing. In other words, at what rate your radius is changing. So what you're looking for? dr dt. What is dr dt? And dv means dv respect to time. So you're looking for your dr. And what is given? The radius. So you have to memorize this formula. The volume of a sphere, is 4/3 pi r cube. 4/3 pi r cube. That's the volume of a sphere. And since balloon is a sphere, so you have to use that formula for the balloon. So we need to take the derivative. What's the derivative of V? dv dt. Easy. Now 4/3 pi. What's the derivative of 4/3 pi r cube? Which one is variable here? The only variable is here, right? R cube. So what's the derivative? So you keep your 4/3 pi. 4/3 pi. And what's the derivative of r cube? Power comes down. What's the derivative of the r? Sorry, what's the power of the r? No, it's 3.
-1.
Yeah, but you have to bring it down as a coefficient, right?
3
3r square, and then the indication, dr dt. Everything is changing with respect to time. In real life, things change with respect to time, unless they are telling you it's the change you're observing with respect to something else. Otherwise, it's always time. So let's clean this little bit. 4/3 pi and 3r square. We can cancel this 3 and 3. Because one of the 3 is denominator and the other is on the numerator. Just cancel them. So we have dv dt is 4 pi r square dr dt. What we are solving for? dv dt or dr dt? dr dt. So if you want, you can divide both sides by 4 pi r square. So they cancel out. And we get dr dt as dv dt divided by 4 pi r square. And now we replace all the numbers. Sayam, did you have a question or did you want to answer? Which one? Did you have a question or did you want to answer? Which one? You did it before, but he was keep talking, so I forgot to ask you. Okay, what is dv dt? 4, it's given to us. 4 pi. What is r? 2. They gave us r here. They gave us dv here. So what happens? What's the answer? You can cancel out the 4s. 4 on the top, 4 on the bottom. So what do you want the denominator? 4 pi. Then what goes on the numerator? Good one. At least you didn't say it's nothing. That's it.
Wait,
And the change in respect to feet per minute, huh?
BBBT is 4.
Yeah. See here?
How about what we mean by 4 feet, 3?
Feet
three?
cubic feet per minute.
Oh, so, alright.
Not tomorrow's test. In the final exam, we'll have at least one from related rate. So there are so many situations.
Wait, on the finals,
I know.
you guys don't give us formulas, right?
No,
Why?
that's why I'm giving you the formula here.
Even the long one
What do you mean long ones?
from the beginning of the,
No, they don't give you anything
why?
because you're supposed to know them.
But you gave them.
I did not make the final exam. So I do I gave them. I gave them in class, not in the final. Come on. Okay, try the next one. It's almost same. I should have changed something different.
Wait, go.
Yeah.
Hey, yeah, let's do this.
Try it. Oh, this time it's the same situation, but instead of putting in the year, you are releasing the year.
Negative. The value is
You're releasing, so it's getting decreasing. Brains, no fun. Let me take that attendance. Same question, just the increasing turn into decreasing. 11, 13. Dominica here, Salahuddin not here, Aslan not here, Maxine here, Zoe here, Jolene here, Prince here, Hayden here, Ellen here, Asir not here, Skyly here, Alice here, Jasmina here, Alexandra here, Jennifer, oh, Jennifer here, Jesse here, Johnny here, Afiz not here, Tarin here, Pedro here, Erika here, Jawad here, Ruby here, Sayom here, Dimitri not here, Siki here, Amir here, William here. Right? I called everyone. You ready?
oh no. I got it. I got it.
Let me have someone else. Tarin, would you like to help me with this one, please? No, you start with V. What is V? No, the formula. No, you start with the original formula and then take the derivative. So what's the derivative? 4/3. Good job. And then
then I got dv over
Mm-hmm,
equals 4 pi r squared
mm-hmm,
dr over dt.
perfect.
Then subtract,
Divide.
divided 4 pi r squared on both sides.
Mm-hmm,
Then they got me dr over dt equals dv divided by dt. And then divided by 4 pi r squared.
perfect.
And then I got 30 pi over 4 pi, even 5 squared.
5 square.
And then that should be 30.
You can cancel out the pi. 4 times 100, yeah. 5 square is 25. 25 times 4 is 100. So what do you have? You just cancel the zeros. Yeah, what's them? And it's feet per minute, no, inch per second this time. You want me to take a fraction, otherwise we'll see it's 311. 3/10. Yep, we forgot the negative sign. Negative, negative, negative. It's actually very important because in the choices, they'll have both positive and negative. So only because of a negative sign, you can get the entire thing 0. So that was our second scenario, balloon. Next, we have a rectangle
Why gospel?
because we have more scenarios. Rectangle, triangle. See? No, rectangle, square, triangle, 3 more scenarios.
But it's all the same.
No. They're similar but not same. So rectangle. Let's see what do you have for rectangle. The length of it, but what they're asking, the area or what? The length of a rectangle is increasing at a rate of 2 centimeters per minute, and the width is increasing at a rate of that. At what rate the area is changing? So we are looking for the area of the rectangle. Yep. So area of the rectangle. What's the area of a rectangle? Length times width. Now what is given to us? Let's observe. The length is increasing at 2 centimeters per minute. What is this 2? The length is increasing.
Oh, 2x.
Length is increasing. Anytime something increases or decreases means derivative. So what is this 2? Derivative of the length. Not only length, derivative of the length. So it's dl
DLT.
dt. It's the derivative of the length and it's changing with respect to time. In the next sentence, they're saying that the width is increasing at 3. What is this 3? Derivative of the width. So dw dt. And what they want us to find? At what rate the area is increasing. So what you're looking for? Area is increasing means what you're looking for? Derivative of the area. dA dt. And they give us the information length is 4 and width is 5 centimeters. Okay. So first you figure out what each number is in the given scenario and what do we have to find. So we start with the area formula. Area is length times width. So what's the derivative of the area? dA dt. How do you find the area on your 2 variables?
Huh?
With 2 variables, right? Length and width. So how do you find the derivative on your 2 variables?
dWL over dt.
So you're telling me to take the derivative of the two variable at the same time? Is derivative that strong that you can change two functions at the same time? Remember I said derivative is so weak, it has the energy to change only one thing at a time.
DL over dt times dW over dt.
So you're changing both of them at the same time?
Oh, what? Wait, one at a time.
You have to change one at a time. So which derivative rule we use if you change one at a time? Chain rule is when you have one function inside another function.
Well, just one.
What symbol you have between them? Product.
Oh,
So which derivative rule you have to use?
are
Product rule.
oh, it's stupid.
You cannot take the derivative of both of them at the same time. Derivative is very weak. It has the life of the derivative is only for a one change. It can change only one thing, and then you have to charge itself, and then it can change the other thing. Okay? So if you use the derivative, if you use the product rule, what's the derivative here?
Would,
If you use the product rule, go ahead.
would.
He's relying on you. Go ahead, no problem.
DL over dt times W.
Good
Plus-
job. dl over dt times w plus dw over dt times L. So product rule says take the derivative of the first, leave the second function unchanged. Derivative cannot change two functions at a time. Then times means you're plusing, you're adding. Then you're taking the derivative of the second one, but leave the first function alone. Okay. So do we have all the information? Do we know what is dA dt?
No.
So this is what you're looking for. Do we know what is dL dt? Good. Do we know what is W?
Wait.
W is 5. Do we know what is dW dt? 3. It's here, derivative of the width.
Wait, why you go through?
Because derivative of the W is 3.
W at 3.
Huh?
W at 3.
It's five.
Or W is 5, 5, 5. See, I said 5, but I wrote 3. What's wrong with me? It's 5, 5, 5, 5. And then do you know the length? 4. So 10 plus 12, the answer is 22. And which unit we use for area? Centimeter or what? Centimeter square. It's area, right? Centimeter square. Oh, it's a rate, so you have to have something over something. Centimeter square per, how they are changing, minute, per minute. Every area has 2 units. Something on the numerator, something on the denominator. Was it harder, confusing? No. Do I have another rectangle? No, I forgot. Then you have a cube instead of a rectangle. Cube. So rectangle lives on which plane? A 2D plane, right? But cube has what type of shape? 3D shape. So we do not have an area for cube. What do we have for cube? Volume. So the same thing as area, but its name is volume since it's 3D shape. We can do one more. And then when you come back after the exam, we can do 2 more to refresh your memory. Okay. So for some reason, the cube is increasing. It's getting bigger and bigger, bigger and bigger. When the cube is getting bigger and bigger, the side of the cube is increasing at a rate of 1/2 feet per minute. What is given here? The side of the cube is increasing at a rate of 1/2. What is this 1/2? It's the value of what? The side of the cube is increasing at a rate of 1/2. So what is this 1/2? Good job. Derivative of the side. Find the rate at which the volume is increasing. What you're looking for? Find the rate at which the volume is increasing. Derivative of the volume when the side is 1/3 feet long. So which formula is supposed to use? Volume of a cube. Actually, let me just write cube instead of drawing a cube. What's the volume of a cube? Length times width times height, but your cube has everything same, right? So how do you write it? Square means cube. So it's S cube. S means side. Volume of a cube is side cube because a cube has all sides same. So this is S, this is S, this is S. So you have S cube. So in other words, if you write it simpler, V equals S cube. And now what do we do? No, V is already alone. Take the derivative. dv dt. What's the derivative of S cube? Three S square ds dt. It's not 5, okay, it's S. S. S, not 5. So 3. Do you know what is side? How much is the side? 1/3. So 1/3 square. Do you know what is derivative of the side? 1/2. So what do you do? 3 times what is 1/3 square? 1/3 times 1/3. 1/9 and 1/2. You can cancel the 3 with the 9. We get 3 here. So what's the answer? 1/6. And since it's area, so it's going to be feet square per minute. Feet square per minute. Oh, let me get on the top. In my method we do. But on the final exam, it will be multiple choice.
Oh, wait, everything's multiple.
Not everything. 22 question multiple choice.
8 questions.
Short answer. 22 or 24, I forgot. But yeah. Good. It's Q. Thank you. Every value has to be cubic unit, cannot have square in it. So that's all about section 1 point, not 1 point, 2.10. We are done at 2.10, but we are going to do 2 more questions in our next class. And then we will start something totally different. Well, not totally different, actually. I should do the money problem first, and then go to the other sections. Then we'll work with more money, more derivative. So please do not be late tomorrow. Do not be late. Come on time. Study smart. Make sure you know all the derivative rules. Power rule, product rule, chain rule, quotient rule. What else we have? Definition of the derivative. What else we have? Where the derivative doesn't exist. Please make sure you study all of those. Good luck.